So I like to think of functions in some kind of a hierarchy. So I start with my function f of x. I find the first derivative, f prime of x. I can find the second derivative, f double prime of x. And then they're kind of going from top to bottom. But what happens if I am given a function, f of x, and I am told that that function is the derivative of some other function, capital F of x? Well, when that happens, this function here, capital F of x, is called the antiderivative. Sounds rather ominous. It's the antiderivative. So, how do we find the antiderivative? Well, here is a function that I'm given, and I'm told that this function is the derivative of some other function. And I need to find what that other function is. Well, the first thing I'm going to do is I'm going to rewrite this derivative, f prime of x, using rational exponents. So this is 3x, well, the power is 3, the root is 4, plus 7x to the negative fifth. Seven x to the negative fifth. Sorry for that. The smart board just stops every once in a while. Plus 1/6 x to the negative 1/2. Well, how I'm going to get to the antiderivative is this. I know, I'm going to take a little tangent first here for a second. I know that if I have f of x equals, let's say, x squared, and I want to find the derivative, I'm going to multiply 2, I'm going to move that to the front, multiply that, and it's going to be x to the 2 minus 1. So the power decreases by 1 when I'm finding the derivative. Well, when I'm finding the antiderivative, the power is going to increase by 1. It's not going to decrease by 1. So what I'm going to do is this. I'm going to go f, no, I'm not going to go f, I'm going to go big F. Big F of x is equal to 3 times some kind of a placeholder here, x to the 3/4 plus 1. That's going to be 7 times some kind of a placeholder here, x to the negative 5 plus 1, plus 1/6, some kind of placeholder, x to the negative 1/2 plus 1. So let's simplify that just a little bit. I have capital F of x is equal to 3 times my placeholder, x, well, 1 is 4/4, so this is x to the 7/4, plus 7, some kind of placeholder, x to the negative 4, plus 1/6, some kind of placeholder, x, well, looks like to the positive 1/2. Plus, and I really should have done this right here as well, plus c. Because remember, I can have, again, taking a tangent, I can have x squared, and the derivative is 2x. I can have x squared plus 3, with vertical shift of positive 3, the derivative is 2x. I can have x squared minus 7, the derivative is 2x. All of these derivatives are the same. But one of the things that the mean value theorem showed us was that I can have an infinite number of functions, all with the exact same derivative, and they're going to differ by a constant. So that's what that plus c is all about. And I was bad in forgetting it the first time, but I remembered the second time, so don't forget it. You have to have that plus c. So let's continue. I've kind of got this really nicely set up. So what I'm going to do is I'm going to say f of x is equal to 3 times, and now the placeholder is going to be the reciprocal of the power that I just did. So it's going to be times 4/7 x to the 7/4 plus 7 times -1/4, that's the reciprocal of -4, x to the -4, plus 1/6, well, the reciprocal of 1/2 is 2, x to the 1/2, plus my constant. Let's simplify a bit. Big F of x is equal to, well, this looks like it's 12/7 x to the 7/4. Actually, going to be minus, because it's a -1/2, minus 7/4 x to the -4, plus, well, 2 times 1/6 is 1/3 x to the 1/2, plus c. So let's be clever here and now take the derivative of f of x, kind of check our work. Well, if I multiply 7/4 times 12/7, the 7s are going to cancel out. 12 divided by 4 is 3x, and I'm going to subtract 1 from the 7/4, so that's going to bring it down to 3/4. Now I have -4 times -7/4, that gives me a +7, and I'm subtracting 1 from the -4, that'd be to the -5th. Now I have 1/2 times 1/3 is 1/6 x. I have to subtract 1 from 1/2 to the -1/2. And then, of course, my derivative of the constant is 0. So let's see. Here is my derivative of big F of x. And it's exactly the same thing as the original function that I was given. So that's a nice step-by-step method to finding the antiderivative.